Alright, so we're going to start with naming ionic compounds, the simplest kind of ionic compounds. Alright? So we're going to start with those compounds where we have metals that only have one kind of oxidation number. Okay? So if I give you something like scandium chloride, SCCl3, and I tell you, write this name, write this formula name. Okay? If I ask you to write this formula name, you need to know if scandium has more than one oxidation number because that affects how you name it. So scandium only has one kind of oxidation number, the number 3. It doesn't have a 2 or a 1 or a 5 or an 8, just a 3. Well, because it only has one oxidation number, we do not need a Roman numeral. We're simply going to name it scandium. Okay? Before you can name any compound, you need to know what kind of compound it is. Because the classification of compound affects the way you name it. Ionic compounds get named one way, covalent compounds get named another. So if you don't know what that is, you can't name it properly. We have a metal bonded with a nonmetal. Almost always that's going to be ionic. If the formula contains a polyatomic ion, that's ionic. So if you have a metal bonded with a nonmetal, or a formula that contains a polyatomic ion, it's ionic. Okay? A metal bonded with a nonmetal, or a formula that contains a polyatomic ion, it's ionic. And you use the ionic naming rules. Okay? If you hadn't written that down, you probably should have. Alright, so scandium is what the front part of this is. If it's ionic, the first part of the formula has to be positive. The second part of the formula has to be negative. That's the only way you can get a neutral compound. Since I only have one oxidation number for scandium, then all I have to do is name this back part. I don't have to figure out anything about charges. Okay? What now? This is unit 4. Okay? So the element here is chlorine, but we don't leave it as chlorine. Okay? When it's a negative ion, a negative monoatomic ion, we change chlorine to chloride. Okay? So the name of this compound is scandium chloride. That's it. Okay, that's the name of the compound. Alright?
But I thought if it had 3, it would be trichloride.
No. That you use those prefixes there, di, tri, tetra, penta, so forth. That's only for covalent compounds. Nonmetals bonded together, 2 or more nonmetals. This is a metal and a nonmetal. Okay. If you have metals and nonmetals bonded together, or if the formula contains a polyatomic ion, that's an ionic compound. You're going to use the ionic naming rules. Okay? When we have just nonmetals, with the exception of carbons that are bonded together, if we have just nonmetals, then we're going to use the covalent naming rules. And then later on, we'll talk about how to name organic compounds which contain carbons that are bonded together. We introduced that briefly yesterday. Remember that? We put carbons together and showed you how you had different prefixes. Okay. All right. Let's do one more of these, only this time let's do a name that you then have to write a formula for. Okay, have a name that you have to write a formula for. Let's see. Zirconium sulfide. Zirconium sulfide. All right. You first have to find zirconium. Okay? And you go through all the periodic table until you find it. Zirconium is right here. Okay, so the symbol is Zr. We need to find what charge number or numbers zirconium has. Zirconium only has one charge number or oxidation number on the periodic table with oxidation numbers. Let's say 4+. If it only has one kind of oxidation number, we don't need a Roman numeral, and there is no Roman numeral here, okay? Sulfide, the Ide ending, is used in 3 situations. The one that applies here is a monoatomic anion, okay? Monoatomic anion means it's usually a nonmetal, single atom that has a negative charge. It's got extra electrons, so it has a negative charge. So we need to find the element that starts with SUL to find the name of the element that belongs there. Okay? So we go through the periodic table. Yes. We go through there, and the element that starts with SUL is sulfur. Okay? So sulfur has the symbol S. We need a compound that's going to be neutral. So let's put down this charge, and let's figure out what charge we're going to put down for the sulfur. Okay, we go to the periodic table with oxidation numbers. And sulfur has 4 different types of charges. Okay? 4 different kinds of charges. We need a charge that's going to give us a 0. So the only possible is -2 because we have to have a negative number. Okay, something I emphasized yesterday. I said it before, but I said it yesterday again for those of you who weren't here yesterday. Oxygen has 3 different negative numbers. Unless I tell you otherwise, you're always going to use 2 negative for oxygen. Okay, you just have to know that. Okay? Oxygen has other oxidation numbers. We're only going to use 2 negative unless I tell you otherwise. Okay? All right, now back to sulfur. Sulfur has a 2 negative. Has to be 2 negative. That's the only way I'm going to be able to get this thing to work out to be 0. But it's not yet at 0. If I did this math right here, I'd have a 2 plus. I need coefficients to make this work out. So what coefficients do I put in front of these to make this work out to 0?
2 and 4.
I could be using 2 and 4, but isn't 2 here and a 1 here simpler?
Mm-hmm.
You want the simplest whole number ratio. Simplest whole number ratio. Okay? So if I need 2 negative charges, and if sulfide has a 2 negative charge, then I need 2 particles with that 2 negative charge. Okay?
And how did you say you got the sulfur? Like, I know it's sulfide, but
Well, when this got named, we took the name of the element because this element has a negative charge, so that's why we call it IDE. Okay? So to undo that, then we got to find the element that has the front part, like this part here, and just figure out what it is. Okay? So now we're ready to put it together into a formula. We have 1 zirconium, just 1 Zr. We've got 2 sulfurs. To show that we have 2 sulfurs bonded together with the zirconium, this coefficient 2 has to become a subscript. Okay?
So you put IDE on the end of the charge.
Yes, that's one of the 3 cases where we do the IDE endings.
So why did you do IDE on the first one?
Because we were naming it. This is where we're naming it. So it's the 2 elements were scandium and chloride, or chlorine, and I'm just showing you how to change that to ide when you have a binary compound. Binary compounds always have an IDE ending. Okay, but negative ions also have that IDE ending, but it works out to be the same thing anyway when talking about ionic compounds. Okay? All right, now you have the worksheet for writing binary ionic compounds. All right, I want you to do the first 4, the first 2 in each column. I want you to name this one and this one, and I want you to write the formula for this and this. Okay? Do that now, please.
Mr. Taylor, do we do like with the theta and the di? Will we do that one on these too? Or no?
Say again now.
Like yesterday, how you taught us to do like the di and theta?
That's for covalent compounds.
Okay.
You have to first identify what kind of compound it is, okay? Ionic compounds are named with a different system. Yeah, I'll be right there. Stay focused on the work you're supposed to be doing. If you need help, you can either get help from me or you can find a neighbor near you who can do this, and make sure you talk quietly to get help from a neighbor, okay? Who needs more time?
I do. I need commercial trip.
Why are you sitting there then?
Because she was doing hers.
Well, get on the stick, do something. Don't just sit there, call me in and get somebody's help.
You know I can help you. Can you want me to do that? Oh yeah, you know.
Yep.
Can we write the formula, you want us to write the charges now with it?
No, the final formula has no charge on it because we've neutralized all the charges.
Okay, it's just got like.
What now? What now? Yeah, once you put it together, see those charges, you can't get rid of it.
Probably makes sense.
I will, except you put a beat my name on it.